We're now going to be taking a look at a couple more ways we can set up this rocky landscape using the existing setup we have, and really just applying a couple of different techniques to modify the terrain. So not just using the smooth altitude or the smooth area altitude, but also taking a look at modifying the vector itself rather than the smooth area, or using both. Which is going to make it a little bit easier to set up materials. So the scene I've loaded in is the rocky landscape _B_02. So if we open up the terrain editor and take a look at the function, what we're going to do is just, instead of using where we have this connection to the smooth area altitude, what we can do is set up a vector offset. Now, we could use the origin to set this up, but I find that a direct offset to the vector input ends up being a little more effective. Now, we are going to need to set up a numeric turbulence for this. And what we can do is first add in a math node vector operation offset, and we're going to connect that to the vector input of the terrain fractal. And then we're going to add another math node vector operation composer 3. Now, a pretty effective way to use this is to use a Z input. So we can really just modify the Z offset. So we'll go ahead and connect our offset now to that composer 3, and we're going to start to see it being manipulated. If you want, you can disconnect the smooth area altitude and just take a look at the offset. And we're not going to see that big of a change right now because our output is so minimal. So if we take a look, that range of 1 is not very large for a vector. So what we need to do is modify this output. What we're going to do is multiply the number first in order to increase its overall scale, and then we're going to offset it. So we're going to add a filter, and we're going to use multiply, and I'm going to go ahead and set that to a value of 10. Doing that, we can already see the changes, which is more of an inverted look, because if we take a look at the output, it is going negative. So if we want to offset this positive direction, we're going to add in another link just after that multiply, switch it to the offset, x plus a, and what we can do is set this to a higher value, say 2000, and we'll see more of a change throughout. So we could also use this in combination with the smooth area altitude if you want to kind of mix that together a little bit more, if the current setup isn't desired. Now we still kind of have that inverted look, so if we have to, we can go to the map filter that we were using before and really just create sort of an opposite setup. So our lower value we can keep around 0. We'll just type in 0, and our upper will set to 1. And that's going to go ahead and invert everything to give us more of the rocks, and rather than the in-between areas of the rocks. Also, the input value, because we're clipping, is going to be really important. So we can choose to change whether or not we want to clip that out. I also want to note that when you're using the map filter and you have clip out of range values and you're using it to control something like this, you can end up with some very harsh cutoffs on terrain features, and depending on the polygon count, it might not look very good. So if you need to, you can switch that over to a different map node being the smooth map, which will automatically cut out anything outside the value, but ease it into the subtraction or the extent of the input. So we'll go ahead and switch that to a smooth map and type in the same values we had before. And that's going to produce a better output. So you can see by switching around this map filter, we can create a lot of different changes. And change our numbers around a bit. We could go into the negative if we want to have more of a range. But keep in mind, because we're multiplying this by 10 afterwards, if the value is too high, and originally we had basically a total value of 1, and now we're up to a value of 3 because it's -1 and 2. That creates a very large vector range, and you're going to see a lot of distortion, and that might be a bit too much. So just one thing to kind of pay attention to. And that's pretty interesting right there. So I'm going to stick with -1 to 0. And then that offset we can modify if you wanted to do maybe 1,000 instead of 2,000. And you can end up with some really different looks depending on this value. So you can also set up, if you want, additional connections on other axes, because right now we still have the X and Y available. So if you want to use, say, just the multiply before that offset, because too high of an offset on the other values now is going to create a lot of distortion. So we could just do the X and add a little more distortion. Because of the way this is set up, our smooth area altitude is going to have an impact on the way it is being distorted, and also the different bump surged areas. But we could still go back too and reconnect the smooth area altitude to that map output, although we may need to reverse it, add in a filter, and set it to opposite. And that does look a little bit better. So now we have a nice vector blend, which is going to change some of the detail areas and mix that along with the smooth area altitude, which is going to give us a much better output from the second output, or the detect rough areas. Because if we only modify the smooth area altitude, it may not entirely take into account the individual features we've added in. So by modifying the vector, that is automatically going to be taken into consideration for that second output, which is going to make it a lot easier to control a variable material based on those features. And that way you don't have to go in and paint everything in, or at least it gives you a good starting point. Now, another way we could mix these together is by using the combiner node blender and connecting the ratio to this numeric output and setting up two different landscapes. I mean, there's really a countless amount of ways to use numeric information to get the kind of look you want and distort other fractals. So I'm, of course, not going to be able to go through all of those possibilities, but hopefully this gives you a good idea of what it is you can do by setting up something like this ahead of time, and then kind of mixing it together with either a current setup, or just keeping that in mind and setting it up ahead of time while you're designing a specific landscape. So this is just a small render of what that current terrain looks like. Pretty neat. A lot of interesting features. It does have a few areas that we have some very jagged tears. Well, not an actual tear, but just some areas that are probably a little too jagged and are going to create some strange shadows. So I'm going to go ahead and save this out, and then we're going to take a look at how we can remove some of those areas, and also remove some of the roughness or jagged peaks that can show up, because there's a couple of options, or some of the controls that are causing or will cause individual peaks to be very small and stick up rather high. So if you want to extrude the terrain and make it a very large altitude, you can avoid having small jagged peaks. So this file is just saved a rocky landscape C01. So the main contributors to sharp jagged peaks are going to be obviously the original input that we made for the rocks and their roughness settings. So depending on how high the roughness settings are, 0.5 is default, and that can sometimes be a bit too much on certain fractals. Right now it's at 0.43, which should be okay. We can probably lower it a bit, but the terrain fractal itself has a built-in roughness setting, which is under noise variation, the variation strength. The lower this amount gets, the more jagged and rough the terrain is going to show up. Also, any of the offsets, if they're too high, we can modify those. But first of all, let's take a look at the variation strength. It ranges from 0.8 to 1. And you can set values that are lower if needed to get an even rougher value. Setting this to 1 is going to give us the smoothest range on the edges. So if you have any very, very small peaks that are just shooting up way too high, a little too jagged, you can modify that variation strength. If it's not quite rough enough, then you can lower the value. So if we bring this down to 0.5, you're going to see a lot of detail showing up on the terrain. So go ahead and set that to 1. And if we need to, we can take a look at the numeric input of that smooth area, which is going down to 0 to 1. And we're using that same map to control the vector and the smooth area altitude, so we may want to set up a different map to control this area specifically. Or you could have did that originally when you started controlling the vector with it, or we can disconnect this from the smooth area altitude altogether. But our input is 0 to 1, so now we can set what our output should be from that. And that should change the range a bit to something that'll work a little bit better, going to -1 to 1, or 1 to -1 if we want to reverse it. And you can end up with some interesting features either way. And it's something that you really have to kind of play around with until you get what it is you're looking for. But either way, it's pretty interesting. So I'm going to change that to 0.5 to 1 and reduce that range, because we do have so much distortion coming from the vector itself. So now we'll be able to extrude this, and we may need to throw in another map filter on the bottom, because right now we're mostly below 0, it looks like. So when we scale it, we're scaling from a higher pivot. And here is just a quick render of what it's currently looking like. So we can see most of those really small jagged peaks are gone. We do have some very large flat areas that don't really have a lot of detail to them. That's going to be really created by the fact that we're clipping with the smooth map. So if you need to extend the range a little bit, you can bring back some detail. So changing that from -8 to -4 is going to increase the range output by those rocks and give us a little more detail. Also changing the smooth area amount will fill in some of those overly smooth areas. If that's not something you want to have, obviously material will change our setup. And we've still got that opposite filter set up. So I can go ahead and delete that. And what we could do is just set that up manually. Because if we already have a map filter, we don't really need to have an opposite as well. We could just use reversed output ranges. I am going to increase the value and go from negative 0.5 to 0.5 as the output, which will allow us to go below and above the typical 0 range of that smooth area altitude, which can change the features quite a bit. And really this will pull out a better looking terrain. So I've gone ahead and saved this as Rocky Landscape C02, and let's take a look at the second output for the detect rough areas, and be able to set up a material layer with its alpha connected to that output. So we're going to start with just a base material. Go ahead and load one in. I'm just going to stick with some of the view content. And let's go over to rocks. We'll start with the gray-brown rock as our base. Let's go ahead and change the scale to 1. And we'll be making some modifications to that probably. But we want to set up another layer now that we can use to overlay this so that's not just defined by the environment tab that we'll see in a minute, or the presence tab. Let's also load in the red-brown rock as an additional layer. So, and I did just cancel that really quick. What we want to do is just select down here, add layer, red-brown rock, and it's going to set our alpha boost to negative 50, which is going to only show, it's sort of like an opacity filter for it. So we're going to set that to 0, go over to the environment tab, and make sure that altitude range is negative 1 to 1, slope range is 0 to 180, and that we have no fuzziness settings. Everything should be at 0. This way, we're going to be able to take a look at exactly what the fractal output from the terrain is going to be without any interference. I'm also going to set the scale to this to 1, and we're set to world standard, so that should be good. Now, it does look like there might be a built-in alpha. There is not, but there's just a lot of similarity between the color, where it is very gray. So I'm going to go into the function for the red-brown rock, and we're going to add in a color node, set it to color correction gamma, connect that. Let's go ahead and set it to 1.3, and we're going to darken it. And that way we should see a more obvious difference. We can also change some of the colors overall, but right now I just want a more clear change between the surfaces. Going into the color variation, or actually it looks like the 2-color variation, where we have this very light color. Let's go ahead and darken that up just a bit. And that's going to be a lot different than the other one. So we'll have a lighter material and a darker material, one red, one grayish. So now we need to go into the terrain. We're going to edit the function, and we need to set up our custom output. So we're going to right-click, add output node, custom dependency. And then we can just give it a name. And I like to put brackets around any sort of custom dependency because it separates it from any of the other outputs. makes it a little easier to stand out and separate what is something you defined yourself rather than the standard outputs. So I also want to set up really quick just a blender where I'm going to connect input 1 to the rough areas, and then connect this custom dependency to that rough area as well. Switch the blender over to 1. You could also set up kind of an on-off switch if you wanted to switch between the rough area and the altitude to be able to see the change. To do that, we can extract the ratio. We can set clip ratio 0 to 1, extract the ratio, change that from a constant number to a Boolean number, and now we've got a checkbox that turns it on and off. So if you want to publish that feature, it does make it a little bit easier to create an on-off switch. Let's go ahead and take a look at that fractal, and now that we have something connected to the second output, detect rough areas, which is something that is available within every fractal, but will only produce an actual output from the terrain fractal, the grainy fractal, the Rocky Mountain, eroded Rocky Mountain fractals, also the strata filter. If you're using a simple fractal with a terrain Perlin noise, that should also produce that rough area output, but most of the other fractals will have no use for that roughness. So it's really only part of these other fractals. So even if the choice is available, it might not actually have a rough area output. So what we can do now is define the feature size. Right now it's very small, set to a value of 0. We can go ahead and increase that and start to see the changes that we'll be able to use to define exactly where the material is going to show up, which material. So let's just increase this. Let's go ahead and set it to 1.5. And we can see those nice rock features in there. If we were to control this with just the smooth area altitude, we wouldn't see any real change in this if we didn't even have the smooth area connected. So this allows us to really connect that offset to the actual material a little bit better, along with mixing with the terrain fractal. So set to 1.5, that is also going to be our rough output. If we take a look at the function node preview and what the output is going to be, it's going to give us basically a value between 0 and 1, or 0 and 0.5, because what's going to happen once we output this is the Z is going to become completely null. There is a way to actually output the Z value. We'll take a look at that if needed. But for the most part, it's going to be a two-dimensional output of the X and Y. So what we can do is define our range within the output of the terrain editor, so that way if we want to connect this to multiple materials, we don't have to set up multiple filters. We can just have one overall filter. So we'll set it to a map. 0 is our input range for the lower value, and 0.5 the upper value, and we're going to set that to an output of -1 to 1. It's going to show us probably going outside the range, mainly because of the Z axis, but that's going to be null. It does go a little bit beyond with the other axes, but not very much, only for very, very small peaks, so this should give us a good amount of control. What we can do is switch this back over to our altitude with our Boolean number. So now we've got the altitude output. You could delete this entirely if you want, but it is a good way to preview three-dimensionally and really kind of take a look without having to render and see some of the finer details based on that second output feature size. Since this is connected to the second output, we don't need to worry about changing anything for that. Go ahead and click OK, close this out, go into our material. We're going to edit the function for the alpha production, add in, so right click, add input node, external dependency, and from the procedural terrain we can choose that rough output. As you can see, the z-axis is completely null. There's no information there. So what it's doing is taking a two-dimensional output and mapping it over the top of the terrain, projecting it downward basically as a flat surface, because that's the way the terrain itself is created. It is a slice of that fractal and not actually the 3D information, unless, of course, you're working with spherical terrains and planetary scenes. Basically, a planetary terrain would be that all of the three-dimensional information, but in this case, it is not. It is just a two-dimensional output mapped onto it in order to match the features correctly. Now, if you want to actually use the three-dimensional output, what you can do is edit the object, go into the procedural terrain, and basically just replace the default position input by adding an input node position options and using the same option. So this is set within the terrain editor. We'll see the mapping mode is object parametric. So that is the mapping mode of this position input. So we can change this to object parametric, switch these over, click OK. And that's going to give us the ability to remove that cut and the automatic clipping that is performed on every custom output, or every output. And now we can see our Z information remains intact. So if you do want that additional fractal information, that is one way to set it up. For now, I'm going to stick with just kind of the default, and we're going to use just the 2D information to try to match features a little bit better. There are advantages and disadvantages, of course, to both, but this should be good to match up our features correctly, and we shouldn't need anything further. So we may need to clip this a little bit more because only really certain amounts are showing. We might want to use a threshold or invert it, which we can do with the opposite. So now if we want to see more of the underlying material rather than the topmost material, we can set it to the opposite. And then what I also want to do is add in another filter in here, and we can use the smooth threshold. Smooth threshold is pretty nice to really cut a feature out. You can adjust the threshold amount, and we should be able to cut out some of these features and map these over each other. The transition is going to be the smoothing of the edge and how harsh the cutoff is going to be. Bringing it down to 0 is going to give us basically a full threshold. Keeping in mind, if we open this up to a value of 2, that's going to be the full range, where we just really have more of a contrast. So anything below 2 is then going to start getting clipped. 1 is the default highest value. So I'm going to use a threshold of 0.75 with a transition of 0.3. The full range -1 to 1. And then let's just take a look at a render and see the distribution of the material based on that output. So if we take a look at the render, we can see a nice distribution between the two materials and a good alpha that was created. And of course we can fine-tune that by changing the threshold, setting up different filters in between, and really get some great control that intermingles with the way the terrain itself was created. So the next thing we're going to do is to improve the look of that gray rock, because it is kind of boring right now. And there just really isn't a whole lot of features to it. We could modify the scale of the material, and also just take a look at the fractal itself and see how we can make internal changes. But connecting it to some of the landscape features can also create a really nice and intricate material that plays a little bit off the altitude. So let's take a look at that larger area that was rendered that has just that underlying rock. And we'll edit the object, and we're going to create an output in order to modify that. And what we can use is either any of these individual fractals to pull out certain features, anything we really want to get a good amount of detail from. We could use the mixed output that's controlling the origin, or we can go in and use the square samples themselves to really get a nice looking variation. What we can also do is add in that position options, and we're going to use the object parametric, and we're going to connect just our rocks to the 3D output. So our custom dependency output of the terrain fractal should remain two-dimensional, but anything we pull off before that final output, we should be able to get a height Z elevation or Z changes that will, it might not match exactly the same, but since the initial fractal is generated from the same noise, the material itself will look really good with it together. So let's use the square samples and connect that to this custom output, give it a name, and take a look at the output of this. We're going to need to map it. So we'll set up a filter, change it over to the map, and then take a look at what our control is. So we're about negative 5.5 to maybe 2 or so. So let's go negative 5.5. Set our output range -1 to 1, and then we can just start bringing in the upper value until we can see our extensions around 1. Now, if this other one isn't quite high enough, it's going to be very difficult to change that and get an even contrast. So negative 5.6, -1, -0.5. So -0.5 looks like the full range because we do have some sharp peaks that do show up here and there that do extend a little higher. So if we need to clip it a little further, we can, but this should be good to start out with. And I'm not going to clip the out of range values. I want to use all of that information. So we're going to use that and connect it to the gray-brown rock. Now, one thing, if you're not aware, is when you're using this dependency output, the scales are locked to the scale of the terrain. So you don't need to worry about changing the material scale and modifying that output. So that is a nice little feature. What I want to do is add in that input node external dependency and choose our square samples. And we want to modify this somehow from that. A lot of different ways we can do that. We can control color maps, or we can multiply. One cool way to kind of keep the initial hues and tones of the initial material and just kind of darken or lighten certain areas, creating sort of a diffusion, is just to use the gamma like we did before, but control that gamma with the external dependency. So we'll connect that to our external dependency. Because the range is going so far below 0, it's going to end up very white, very light color, so we do need to either offset it or set up a map. Since the map basically has a built-in offset control, we'll just use that. So our input will be -1 to 1, and then we set our output. 1 is going to be the brightest amount. Anything going above 1 is going to start darkening. and then we'll be able to see those features start to show up. And you can see how we can darken that up. If you want it to go lighter, then you'll have to set your lowest value to be below 1. So if you do want some areas to go a little bit brighter, you can adjust that, but I feel it's already fairly bright. And then we can also modify and cut out specific areas. And really it's a matter of just kind of picking and choosing what's going to look best, and whether or not we need to cut anything out. So let's go ahead and set this to 2.5 for the lower value output. So we're kind of inverting it. 1 for the upper. And let's see how that looks. We may need to make some additional changes, but we should get a nice overall change. If it's blending together too much with the other material, we can of course modify that in the additional colors. And I'm going to stop the render here. We can start to see some nice changes, but I do want something that is going to be a higher contrast. In those spikes that were used to really set the upper value, I think are kind of interfering. So let's go ahead and change the upper value input range to 0.25. We can also start clipping the out of range values, and that way we're not going to cause any areas that are going to be really, really bright or just way too dark. So that should give us a little better contrast. We'll take a look at that. And that looks a lot better. What we can also do is we don't really have a bump defined. So if you do want to also have a connection to the bump, right now the bump channel is just a very simple terrain fractal. We could improve the look of that by adding in a combiner node set to Blender and connecting input 1 to our external dependency and adding the square samples to that, which we can also see that z-axis is taken into account. Now we don't want this to be as high of a value as it is right now. The output range between the two inputs is a very large difference. Also, because of the offset, we have everything basically going in. So anything below 0 is going to create a bump that goes inward. Anything above 0 is going to have a bump that goes outward. So what we want to do is take this connection, add an offset. We're going to offset it by 1, so we're going to make it go a lot higher. And then going back into the Blender, we can just add a smaller amount, say 0.01 or 0.05 of a blend. And then our total output, if we take a look, is set to 4.5 for both of them. So if you need to reduce that amount, you can. I like doing it within the function because that way you still have the original material, but along with the new bump that we can control and define a little bit better. So now we've got some nice features showing up that we can see with that improved bump. And really kind of a matter of tweaking things here and there to get exactly what it is you're looking for. But it does create a nice mix. So I'm going to go ahead and just kind of move the camera a bit so we can see more of the terrain and render that out a little bit larger. Be able to see things a lot better. So the distribution looks really nice, and with the connections to the custom outputs, now really seeing the bump in there. It looks really nice. There are some jagged looking edges, the kind of triangles showing up, and that's because the individual polygons are changing too much between those areas, so there really aren't enough polygons being generated in order to transition that enough. So what we can do to increase that quality is just to increase the quality boost of the terrain itself. So editing the object, going to the quality boost, and then we can start to increase that amount, which is going to increase the resolution of the terrain. And then we'll be able to render that out without any problems. Depending on where the sun is showing, where light is coming into the scene, some of those features are going to be showing up more obviously than other locations. If the sun's up at a very high pitch, you're less likely to see some of those shadows and artifacts. One thing you could do too is to get rid of the ray tracing and use a shadow map. So if we were to, say in this case, take a sunlight and use a shadow map, so double click on the sunlight, go use shadow map, click on the auto size, and I'm going to set the ratio up to 100, which is going to create a sharper shadow. And now because we're using a shadow map, which is going to render quickly or much quicker than the ray traced, what we can also do is go into the terrain and turn off the fast shadow option, and that can usually help. So that definitely looks a lot better now using the shadow map. We don't have to worry about drastically increasing render times by subdividing the terrain further, and we still get nice shadows throughout without all of those really jagged triangular looking ones. And also being able to turn off the fast shadows option does pick up on more of the detail. Increasing the ratio will also pick up better details, because with a ray trace shadow you really see lots of small features from the procedural terrain that you really typically don't get with the default shadow map settings. So increasing that ratio does pick up those extra tiny bits along with the regular shadow option and not the fast shadows. Fast shadows is the default, and rendering without fast shadows in a ray trace mode does take a really long time. So it's really something you don't do unless you need a lot of shadow quality from lots of tiny features from the terrain, but it does significantly increase render times. So this is a nice balance between the two. So I'm going to go ahead and save this scene out as Rocky Landscape C03, so you can load it in if you want to take a look at it. And just remembering, if you do decide to change the shadows to ray trace mode, that remembering that the fast shadows option is turned off. So if you're experiencing very long render times, it's because of that option. I also want to make just one final note about using that ratio option. And one thing you may have noticed is that when I changed the ratio up to 100, we ended up with much larger and softer shadows. The ratio itself is basically 1 is equal to the size of the frame and the render size. So when you change it to 100, it makes the shadows a lot bigger, and some of the smaller shadows will be removed, and what you end up with is kind of an overall blending of the light and the different shadows. Setting it to 1 can give you smaller shadows, but less kind of blending and variation throughout. If you do want to set a smaller ratio in order to pick up and have an equal lighting with kind of smaller shadows that match a little more to the ray trace, without having to use the softness. I'm not a big fan of the softness amount, just because of how grainy it can be. So setting this to 0.1, I just want to show you what this looks like. I like to use a larger amount because I think it reacts a little better with the way the materials are set up. And in combination with global illumination and additional lights, you can really get something that looks a lot better. But it will change, obviously, the positions or the larger shadows and kind of change those around. So you don't always want to set the ratio that high. It's just one of my personal preferences. But I also use different lighting situations as well on top of that. And right now it's really just set up with one light. So I just want to show you what it'll look like. Obviously this is in a different position now than the previous render, but just kind of taking a look at it with a value of 0.1, and it will remove a lot of those jagged edges and still look good, but match a little bit better to what the ray trace looked like. So here is the a completed render with the ratio set to 0.1. If you're noticing, and sometimes this can happen, that a shadow might be cut off early, then you will want to set that to at least a value of 1. What I prefer to do overall, and the reason why I like using the higher ratios for the shadow maps, is because if you take a look at this, it has a very sort of cell shaded look to it, where it's kind of flat, and the lighting and the features don't really kind of mix well without a more complex setup. So it does allow you to just kind of quickly render something out with a little bit of a better look. One thing you can do that I really like setting up is using the relighting. Set the ratio of the sunlight to a value of 1, copy and paste it, create another sunlight with a ratio of 10, copy paste, ratio of 0.1, copy paste, and set the ratio to 100. So now you'll have a bunch to choose from. You can go to your render options, enable relighting, and then just kind of blend and mix those together after the full render. So once the render is completed, we have in the post-render options, and if that doesn't come up, you can just click on the icon for it, which is next to the save option, and we can go in and define the individual lights and really customize the shadows a bit more. If you're using version 9 and not 9.5, you will not have the ambient option that was added in 9.5. But you can see how we can go through and then fine-tune and get something that looks a little bit better. Also, turning off the natural film response will help pull out some of the other details when you're relighting. So we can maybe turn down our ambient light a little, and then we can just start to tweak each of the different shadow qualities to end up with something that looks a little bit better. So it kind of gives you the best of all of the different sunlight shadow options and different ratios, and allows you to kind of mix that together and make something that looks exactly the way you want it. So relighting is really useful for that. Now I'll go ahead and save this setup in this version of the scene with the new lights as CO4.